Okay, for our last part, let's just kind of look at distribution and factors that affect the distribution of ecosystems and so forth, species interactions. Now, again, everything can't live everywhere, and you have these factors, physical, chemical, biological factors, that determine species distribution and population size. If you have too little or too much of something, that will affect a limiting factor, low temperature, the lack of water, or lack of active chlorophyll. That will affect the distribution, so it's a limiting factor. You can have specialist species that can only live in a very specific area, like pandas, for example. Or you can have what we call generalist species that can live almost anywhere. Rats are a good example of that. So here's some examples here. The coast redwoods over here on the west coast, they are specialists. They can only live in a very specific area, whereas red maples are more of a generalist species that can live over here in large parts of North America. You have uh, things that can upset the ecosystem, but disturbances like storms, flooding, wildfires, volcanic eruptions. Then we also have what we call ecological succession, where the ecosystem is disturbed enough by perhaps one of these that most of the species or all of the species are removed, and the area undergoes a change in species composition, and newer species or newer communities replace the old ones. So you might have a wildfire, for example, or a volcanic eruption, and that will remove the current species, but over time, a new species will come in and replace the older one. Fire is a really good example of this. It's natural in some cases it's man-made, but ecosystems tend to adapt to fire, and depending on the severity of the fire, different species will be affected. So watch the forest fires video over in the weekly chapter module. And so this is in your book, and it will discuss this in a little more detail, and I'm going to go into. That's what happens is surface fires eventually will destroy all the trees, but and that will change the environment underneath. So you have fire suppressed forests, fires that have more frequent forests. So the greater the distance between the surface fuel, the more difficult it is for the crown fires, the fires that affect the growth of the tall trees, for example. Now, we can have what we call terrestrial succession, and we have secondary succession. So, where you have bare rock or a disturbed site without soil, we have what we call the primary succession, the beginning stage of an ecosystem. And you start to form what we call pioneer communities, the first species that come into the ecosystem and start to habitate in the ecosystem. And to get soil, we get a secondary succession, where we start to get more communities in there. This is in Hawaii, but notice the lava has come down. So it's bare rock or a disturbed site without soil, but then as it starts to break down, this is your pioneering species here. We start to see the growth of plants, and it will eventually lead to more communities coming in. Another example, so here's right after the fire, and then 1 year later, the new species have come in and populated the area. Now, Helens was what we call secondary succession. So you have soil as present. Okay. Here's where Mount Helens was. So you had this massive volcanic eruption or massive eruption, and then displaces large portions of the ecosystem. you have soil that's present, and species come back in and repopulate it. So it's disturbance and succession. That's how it works. It works in water, aquatic succession, where you get the gradual enrichment of water from plant body or water bodies from plant material and organic debris. So here's open water. You get more plants, more sediments. Eventually, the lake fills with organic and inorganic sediments. The open water area starts to shrink. You get a bog and a marsh, and finally a meadow. So it's these different succession of ecosystems. So you go from or from a lake like this, you raise the organic content. This is very common in mountain lakes, and eventually you'll get a bog. Now, ecosystems are stable, but they're going to be constantly changing. They don't diverge greatly from its original state. That's when ecosystems are stable. And if they're resilient, their ability to recover from a disturbance, that increases their stability. So what you want is an ecosystem that is stable, but also exhibits a high degree of resilience, meaning that as a disturbance, like a fire, for example, it will recover and won't diverge too much from its original state. We see these a lot in fires, for example. So it's prairie grassland, again, it's had a fire, but it's relatively stable because it's resilient, meaning that it's repopulated with basically the same types of plants that were there before. On the other hand, you had a stable system that's not resilient, like a rainforest, that's heavily logged. It's not going to recover for a very long period of time if it ever does. Now, biodiversity has been on the decline because of human activity. It's dramatically impacted the number of species as human populations grow. They modify the environment, the ecosystems for their use. And so we see habitat loss for other organisms, degradation of the environment, for example, and humans introduce air and water and soil pollution, unsustainable resource use, climate change, and humans will introduce invasive species that's not native to an area into a stable environment, and that will upset ecosystems. So the deeper the red, the more biodiversity, and you want everything works better if you have a higher degree of diversity. Bluer is lower, noticeably, especially in the desert, because the environment isn't conducive, and also in ice areas, it's not conducive. It's too cold, too hot, little moisture. So you don't get any type of habitable ecosystem there. So hardly any diversity. But as humans encroach upon this, and we go back a couple slides, so we start to get this ecosystem that's not resilient, being disturbed by logging, we start to lose this biodiversity. And more diversity, that ensures greater survival of more species. If you have fewer species and then something comes along that can disturb them, it might kill off the species because there's just fewer of them. And amphibians are particularly vulnerable to this, and that's why they are kind of the baseline for any type of climate catastrophe. We've seen this slow disappearance of frogs, for an amphibian frog, for example, and even turtles. So these are threatened and climate change susceptible. This color here, over here, and not threatened, but climate change. They're not yet, but they were very susceptible to climate change. These are ones that are threatened and are also susceptible to climate change. Now you can restore ecosystems where the number of organisms at one trophic level changes in response to the number of organisms at another trophic level. Remember, you have these different levels, anywhere from 3 to 6 within each ecosystem. So this is in the news even today, where you get this environment, in this case Yellowstone, without wolves. So you have increased the number of coyotes that ate the small mammals, so you reduce the food for other things. You get an increase in elk, but they eat the streamside willows and shrubs, and that decreases fish and bird habitat because the water gets warmer. So you introduce wells, the elk population gets cut down because wolves eat the elk. Bison increase because there's fewer elk. Pronghorn sheep increase because now there's fewer coyotes that prey on the pronghorns. And beavers that create ponds in their habitats, which increases fish, amphibians, insects, birds, and streamside vegetation increases, so you get stable stream banks, which provides cooler water, which means better fish and bird habitats. And because wolves don't bury their kill, there's more food for scavengers. So, all because wolves were reintroduced back into Yellowstone. So we increased the biodiversity and that improved the whole ecosystem. Okay. So it's an interesting chapter about how all that works, and it's important to understand because of the role it plays in our world today. And you can go over and look at the wolf video over on Captain detail about why the whole wolf discussion is important to maintaining resilient